Good afternoon, everyone. My name is Ifayefunmi, a student of ИАТЭ. And this afternoon, I will be presenting on measurement of radon concentration in some selected houses in some part of Nigeria as a function of time, temperature, and relative humidity. And as we all know, radon is a reactive compound which rarely occurs in the environment. Radon enters the environment through different ways, through the soil, phosphate mine, through uranium, or coal combustions. And radon occurs in the environment mainly in gaseous form. So definitely, people are mainly exposed to radon through breathing of air. As we know that radon is colorless, so you cannot really detect it at standard temperature and pressure, and it is most dense gas, no. Then we have three isotopes of radon, which is 291, 220, and 222. Then the background level of radon in outside air are generally quite low, but the indoor location level is more higher. Now, this is a picture of how radon enter the home. We can see there are different ways from a cracked, fractured bedrock. It can enter through the soil. It can even enter through our shower, through windows. So there is no way in a house we can prevent radon from entering. The only thing we can do is to minimize. Even the materials of the house can also contribute to the amount of radon concentration in a building. So airborne concentration of radon and its project varies from time to time, depending upon the meteorological condition, such as temperature, relative humidity, wind speed, rainfall, etc. But in this work, we measure the time-to-time variation in equivalent equilibrium of concentration of radon in an indoor environment of a selected house, and it was performed at a height of 1.8 meter above the ground surface for about 30 to 60 days. So this is this device that we use. This device was produced by Quarter Radar in Russia here. We use this device to take our measurement. It is called Radex MR107. And this unit is designed to detect and measure the equivalent equilibrium volumetric activity, which we call EEVA, of radon 222 in the air, as well as the activity decay products commonly called the daughters of radon. Radex 107 can detect dynamic changes in gas concentration, sound an alarm when the gas levels are no longer safe, transfer data onto computer for analysis. And so these are still more of the functions of this device. These are its features, what it does. But one disadvantage of this device is that it does not take any measurement that is below 30 becquerel per meter cube, which is also a disadvantage to anyone that wants to use it for a research purpose. This device does not take readings that is below 30 becquerel per meter cube. So from our result, we tried to what we did dose estimation for the annual absorbed dose and the annual effective dose from our radon content that we got. And these are the formulas that we use in calculating both the annual effective dose and the annual absorbed dose. So from our results, we discovered that in one of our locations, because our device could not take any reading below 30 becquerel per meter cube, so 30 becquerel per meter cube was our lowest point, while our highest point was 57 becquerel per meter cube. And our annual effective dose, when we did the calculation, we discovered that our average annual effective dose is a bit higher than the 1 millisievert required by the world standard. Also, for the second location, we discovered that this one is a bit higher, where we got about 90 radon becquerel per meter cube. And definitely our annual effective dose is also higher than the minimum required standard. So this was the result that was produced from the device. The device gave us this result of the movement of our radon, our temperature, and our relative humidity. And we can discover that the movement of the radon, the temperature, and relative humidity are not constant. they varied from one time to another. We can discover that when we look at the dates, the date here is 19th of April 2021 till 24th of May, which is more than a month result. And this result shows that our radon is not always constant. It can be up, it can be down. So the reasons are this. What are the factors that causes this radon to move? And this this is placed in a what? In a standard in a fixed position. So why is the radon changing from high to low, low back to high? So there are a lot of factors. Our meteorological factors can be involved, geological factors, maybe the materials that were used in constructing the house, maybe forced ventilations and the rest. So all these factors must be put in place for us to model, what's it called? For us to model a theory that can help us to get our indoor radon concentration. So we try to do what? We try to check the correlation between radon and temperature, since temperature and humidity are part of the meteorological factors. And from our correlation, we got that our R to be 0.9, which shows that there's a correlation between temperature and radon, and with, with an exponential correlation of 0.9. And this implies that our temperature also influences the amount of radon concentration. And there are also the research work that also are in line with this, that our temperature also influences radon concentration. And we also did for humidity, but for humidity, the correlation was very, very low. So the correlation may be regarded as insignificant. So in conclusion, the average annual effective dose is higher than the permitted value of 1 millisievert. Our meteorological parameters such as temperature and pressure has a direct influence on the amount of indoor radon concentration. The indoor radon concentration shows a non-linear movement for a longer period. And with this now, the next thing we are supposed to do now is we are trying to what? We're trying to do an estimation, get an equation that can help us to determine our indoor radon. And this has been done in South Korea. I don't know if it has been done in Russia, where you can easily determine the value of your radon and a lot of factors has been put in place. So this I'm also working on. Soon the result will be out. Thank you.